All right, we are live. So the scapula, this is going to be the reason I saved it for last, is this is our first and only functional circle that is not transversely viewed. Okay? This view is of a frontal view or a side, a back view. And what I tried to put into the screen to reinforce that is literally a spine, to remind you that you're literally looking at the scapula like you would be viewing it on the back of somebody's shoulder. So in other words, we are literally looking at it like this. The triangle is meant to represent, hey, you're looking at the scapula from the back. And it's the best view because if you remember from 310, the scapula kind of floats. It doesn't move like the four joints that I taught you in 310. Glenohumeral joint, that's your shoulder joint. Then you had this weird AC joint, right? Then you had the sternoclavicular joint, and then you had scapulothoracic articulation. It's not like a true joint. So we can't treat it as such. The only rotation that kind of occurs at the scapula, even that is weird, would be in what we perceive as frontal, mostly frontal, and I have a little dot that represents that. And look at the key. Upward and downward rotation is going to occur about the dot. Upward and downward rotation. That's what we did in 310. Yes? Upward and downward rotation from 310. So the way the circle breaks down with a posterior view is things on top of what we call a bilateral axis are going to be our elevation pullers. That makes sense. Things on top are going to pull up. Things on the bottom are going to pull down. Those are going to be our depression pullers. And then notice I even added extra context. Retractors pull towards the spine. That kind of makes sense. I need muscles that are going to try to pull the scapula toward the spine. And then I'm going to need muscles that try to pull the scapula away from the spine. Those are going to be protraction pullers. So we have elevators on top, depressors on the bottom, protraction pullers, retraction pullers, and then we have a merry-go-round, and that's going to be upward and downward rotation of the scapula. That makes sense? I tried this since I got some good feedback on the red, or we'd circle like, hey, this is one muscle that's made up of different fibers. I've included that in the key. So like I put trapezius, all fibers in red to remind you that. So I'm learning. Getting better as we get better. Okay, look at this. For you list people, I love you. I just want right answers. But look, I put all the functions right here. So in other words, if you can't visually see it, that's okay. But I'm telling you the functions that you're going to be accountable for the test. Okay? Pec minor. Depressor, we're going to go over the muscles, but I'm just showing you. Depressor, protractor, downward rotator, serratus anterior, protractor, upward rotator. Levator scapula, elevation, pull of the scapula. Elevator, retractor, downward rotator, rhomboids, elevator, retractor, downward rotator, and then our super cool, my favorite muscle of the scapular trap, because that thing just looks like it shouldn't function at all. It's weird. They got fibers going all over the place, and hopefully by the middle or in the class, it's going to be like, that makes sense. So again, for those of you just coming, I wanted to do the scapula today, so that way you have today, tonight, all day tomorrow to study shoulder and scapula. And then on Friday, we can literally use that whole day for review and clarification. Right? As always, I try to start off with a little holistical view. This one image pretty much has all of our muscles. It's really not a lot in terms of pulling on the scapula, okay? So we're gonna have our trapezius, you see levator scapula, rhomboids, pec minor, and serratus anterior. I will say, these are muscles that are specifically tugging on the scapula itself. if you're holding yourself in a dip and you're preventing elevation, you're going to be using lats and pecs because it crosses the scapula to get to the shoulder. Like if I pull down on my shoulder, it's going to depress my scapula. So that's kind of a grad school thing, that you're going to have bigger muscles. Like, man, I can do all this stuff with my body weight just using these little muscles. These are just scapular pullers in terms of just on the scapula, but you have things that cross the scapula to get to the next joint. I'm not holding you accountable for this class, okay? But just in case if your brain was kind of twirling in that direction. Reminder about motions from 310. Elevation, so we're going to have elevation pullers. Depression, we're going to have depression pullers. Retraction, we're going to have retraction pullers. Protraction, we're going to have protraction pullers. Upward rotation, we have to have upward rotation pullers. Downward rotation, we have to have downward rotation pullers. Cool? Pec minor, pectoralis minor. Your major crosses into the shoulder. Look, I remembered my bones today. Remember I was trying to tell you, lady between two majors? Look at these three little slits. So the lady in between two majors, pec major and teres major, okay? So the pec major is pulling on the glenohumeral joint, the shoulder joint, but the pec minor isn't. The pec minor starts off on ribs 3, 4, and 5 and goes specifically to this coracoid process, which we've heard before. This is part of the scapula. This is an anterior knob or protrusion to help muscles get a leverage to influence scapular motion. Okay. So the pec minor, I think the easy one to see with this picture is the depression pull right down. Kind of easy to see. Two-dimensional picture, hard to see a three-dimensional concept. So I'm going to rotate over and notice I'm not just pulling down, but I'm trying to pull the scapula forward. If these ribs are more anterior than that coracoid process, in other words, this picture is going anterior to posterior. There's depth there that we can't see from this two-dimensional picture. In other words, this pec minor has a posterior run to it where it wants to bring the scapula towards the front of the ribs. Does that make sense? Kind of harder to see here. You know where it's probably easier to see? Here. Look at that. See the pectoralis minor? How it would be trying to pull that coracoid process forward? Yes? So it has a depression pull. It has a protraction pull. And then I'm going to try to do my best to explain the downward rotation pull of the pec minor. Think of the scapula as a teeter-totter, okay? And we're going to represent the teeter-totter with the spine of the scapula. Okay, so far so bad? So the spine of the scapula is going to be our teeter-totter. Now, unfortunately, this scapula is fused, right? It's screwed in. I can't move it. So all I'm going to do is just take this piece of paper and say, hey, here's our spine of the scapula. Wouldn't it make sense that some muscles that are trying to spin the scapula teeter-totter this way would be upward rotators, and muscles that are pulling on this end of the teeter-totter would be downward rotators? Let me use a right since our circles are right. Here's the spine of the scapula. This is a teeter-totter. Here's the axis for scapula upward and downward rotation. So it makes sense that some muscles are going to try to pull the teeter-totter this way, and other muscles are going to try to pull the teeter-totter this way. So the pec minor, this coracoid process is on one end of the teeter-totter. The teeter-totter is really like this. And some muscles are going to try to pull in a direction of upward, and the pec minor is trying to pull in the direction of downward. See how it's pulling on one end of the teeter-totter? Pulling on this extreme end of the teeter-totter. So you're going to have some muscles that are trying to upwardly rotate, but the pec minor is trying to downwardly rotate, which kind of makes sense. Depression, downward rotation. Not all the time, but in this case. So by pulling on that coracoid process, and that coracoid process is far away from the rib side, the vertebral border, it's trying to pull in a direction of downward rotation by pulling on this end of the teeter top. Okay? And that's pec minor. Guys, pec minor, very prone to getting super tight because of our posture. Trying to stretch that pec minor as a scapular muscle is going to be important for those of you that go off to grad school. Don't get pec minor and pec major confused. Pec minor is scapula, pec major is shoulder. Here's another good view of the pec minor, deep to the pec major. So in other words, here's the pec major. We can't even see the minor. We take the major out. There it is. Soleus and gastrocnemius. Okay. All right. Another one of my favorite muscles, serratus anterior. Has anybody ever seen somebody do that party trick where they put their arm back here and their scapula wings out? Yeah. That's this muscle. So remember, the scapula is literally floating on the thorax, on the ribs. It's not a true joint. It's floating back there, and it's held together with negative pressure like a suction cup and muscles. And the serratus anterior, serratus, a serrated knife, right? And anterior, it's pulling forward. How this muscle works, this is the muscle that if you see somebody with very low body fat, you'll see like these finger-like projections on their ribs. Okay? It's really cool. It starts in the front, but it passes in between the scapula and the ribs, almost like, I think my analogy I use in class is like, if the scapula is a piece of bread and the ribs are another piece of bread, this is like deli meat that goes in between. It passes in between. It inserts in this blue border, the vertebral border. I found two good pictures that show through the dotted line. So in other words, those serratus anterior pass in between the pieces of bread and literally pulling on that vertebral border. So you can see how it would want to pull forward. It would want to protraction pull on that scapula, bringing the scapula to the front of the ribs. And so one of the issues with winging is that if that muscle isn't doing its job and innervating enough for a protraction pull, then the scapula can retract and wing out. Mostly common in non-dominant arms. Usually your dominant arm gets a heck of a lot more recruitment of your serratus anterior. So it's typically the non-dominant that'll wing because you don't really do as much activities a day to live in that. But exercises like working your protractors, that's why that would work in your serratus anterior, because it's literally pulling your scapula forward, pulling your scapula anterior.
What do you mean by
Winging is, what a question. And it's, when you see it, I think hopefully you'll be like, oh, I've seen that before. We all know someone that has this.
Is it whenever like scapula like sticks
Yeah. Oh yeah, and it could be creepy. It could be. See how this one like kind of pokes out?
Yeah.
See how that one kind of pokes out? And it's usually the non-dominant arm, because again, our dominant arm, that serratus anterior gets innervated a heck of a lot more than the non-dominant. So because that muscle isn't innervated enough, then it'll allow more floating back there as opposed to maintaining that protracted position. All right, serratus anterior, protraction puller. I think that's pretty obvious. The one that's not as obvious that I'm here to help you guys with is its upward rotation pull. It has an upward rotation pull of the scapula. I'm going to use a very silly analogy, but I love silly analogies. If in the Wild West, they might have a scene where the cowboy is chasing the bad guy and throws a rope around the bad guy, and the rope falls to the feet of the bad guy, and the cowboy rides off, and that rope is going to pull at the bottom of the bad guy's feet and rotate the bad guy from himself like this, okay? Here's the bad guy, rope pulls this way and tries to rotate him like that. So what I'm saying is that the serratus anterior, even though it has a vertebral border the whole way, 90% of that pull is underneath the axis of upward and downward rotation. So in essence, the serratus anterior is pulling the feet or pulling the body in a direction of upward rotation. That makes sense? Upward rotation puller. Now, we know that we can selectively innervate stuff. But because so much of that muscle is underneath the axis, we're not separating it into like superior fibers and inferior fibers, because there's just a small little bit. So if you say, well, if it's pulling in a direction of protraction, what's stopping it from upwardly rotating? Well, lucky for us, our pec minor is a protraction puller and a downward rotator. So again, it's kind of cool how like they can kind of cancel each other out and work together to just protract. And when I need upward rotators only, as we're going to see with our trapezius, then my pec minor is like, great, I get to take a break. Go ahead, serratus, do you think? Has anybody ever noticed, stop. It's a cool fact, but I think it's going to get in the way of progress. Okay, so can everybody understand? Protraction puller, and then all of these fibers down here are trying to rotate the scapula upwardly. Cool? Serratus anterior, here's another great view. I forgot I found this picture, but a great view. And what I like about it is you can see through the bread. You can see how the meat goes, passes under the bread, and it's tugging back here, trying to pull that scapula forward, and it would try to rotate that scapula up. Cool. All right, lucky for us, we got a few easy ones. Levata scapula, as in elevata of the scapula, as in elevation puller of the scapula. So it's going to be pulling up. You can just look at it and say, well, muscles only pull. Yep, pulling up. In addition, it's trying to pull the scapula closer to the spine. This is kind of at an angle. So elevator, retractor, kind of makes sense. Now let me try to explain its downward rotation. I just realized I have books, and books have spines. That's kind of cool. So this would be spine of the scapula, spine of the book. Cool. All right. Watch this example. Levata scapula. Come in here. The axis of rotation, of upward and downward rotation, is more like further out. Think of it like this. When I upwardly, I'm curling my fingers just to show you how that muscle is going to be lengthened as I upwardly rotate. As I upwardly rotate, this muscle is going to be stretched. And so when it pulls, it's going to pull in the direction of downward rotation. I'm going to do that again. When I upwardly rotate, look how this muscle is going to be stretched. Teeter-totter pull, it wants to pull it back down. I upwardly rotate, it wants to pull me in a direction of downward rotation.
Because it wants to be on slack.
Well, it's just how it pulls.
Okay.
It's just how it pulls. So what I'm trying to use like an extreme example of how if the muscle is pulling here, if I do this, it would want to make me do this. It's really hard to tell mechanically here, but once you kind of give it some upward rotation, I think it's just easier to see how it will want to pull me back down. Because remember, all of this is just how it pulls. That's all. That's what this class is about. Is how does it pull? How do they pull? What directions of motion do they pull? Even better news is levator scapula is kind of hard to see because its angle of inclination is really steep. Rhomboids, I think, is super easy to see. Rhomboids are very easy to see. So you tell me, is it pulling the scapula to the spine or away from the spine? So that this is a posterior view. So that muscle is, you see it now? Because I can see how, yeah, I can totally see how if this was a front view. So it's a posterior view. So it's literally trying to pull the scapula to the spine. So it's going to be a retraction puller. But it's not just across, kind of has an angle to it, right? So in other words, there's a verticalness to it. There's an upward pull to it. In other words, it's trying to bring this end of the scapula higher to that end. Y'all remember chutes and ladders? Chutes and ladders? It's kind of like a ladder. And we're trying to bring this part at a higher spot.
With looking at like I guess the line, like the strokes, could you say that would kind of help you with knowing the direction you would be trying to pull it in, or it's not always like that muscle is going to be? Because you know how I'd say it's pulling to the spine. I mean, if you kind of look, I don't know, it's just my brain.
No. I'm just trying to understand what you're asking.
Like,
It's
like
not
you
that
see
bad.
how there's like all
Yeah, so those are different muscles.
I know, but
Yeah.
I'm just saying, like with the highlighted red,
Yeah. Yeah, it's trying to
It's
pull.
trying to pull.
Yeah, and that's the elevation pull. Yeah, that's what we were talking about. It not only has a retraction pull, but it has an elevation pull too. Like if you're doing shrugs, those rhomboids would be trying to get your scapula at a higher position. Does that make sense? So your brain was looking at it logically. Hey, it's not just pulling medially, but it's also pulling superiorly. It's pulling up and across. Cool? Absolutely. Very good observation.
I think I'm struggling to see why it's a down rotator, and I think it's.
I didn't talk about that yet, but I could see how you would struggle because it's not easy to see. But hopefully, if I do my job, you're gonna be like, I got it. And to me, this is the best parts of the conversation. Show me how it pulls like this. That's my job because I couldn't see this until someone showed me how it pulled like that. Let's say this is our scapula, okay? The rhomboid is running like this. Do we agree? My fingers represent the pull. Upward rotation. Downward rotation. Yes, ma'am. Yes, ma'am. Or another way to look at it is, even more specifically, it's trying to pull this bottom part. Once I rotate this way, it's trying to pull the bottom part back to the spine as well. Make sense? Sure, with the very expensive props. This is what works for me, because I can't explain it. Upward, but this muscle is pulling in a direction of downward. It's an elevation puller, it's a retraction puller, and it's a downward rotation. Yes, sir. Okay. Remember, directional pull. Rhomboids, retractors, elevators, downward rotators, because that's how they pull. Here's another view of the rhomboids. Ooh, here's maybe a better way, I say a better, but just a different way. I think you could visualize how when I protract, those muscles would get longer. They get stretched. If I protract, those muscles would get longer. That means they got to pull in the direction of retraction. If I depress, those muscles would get longer. They get pulled apart. It means they got to pull in the direction of elevation. And when I upwardly rotate, when those muscles get longer, so that means they're going to pull in the direction of downward rotation. Just another way to see it. When I protract, I stretch it. When I depress, I stretch it. When I upwardly rotate, I stretch it. That tells me they pull in the direction of retraction, elevation, and downward rotation. Guys, this is it, man. This is the last muscle that you can have to know in this class. This is a freaky muscle. But hopefully I'll do Dr. George some service here in teaching it. Fan-shaped muscles have to have something in common. You can't have the same muscle not do something in common, okay? This muscle of the trapezius has different fibers, like in your list, right? We're gonna have our upper trap, we're gonna have our middle trap, and we're gonna have our lower trap. It's communicated here. Upper is more on top. Remember, this is a back view, posterior view. So upper is gonna be on top, pulling up. Lower is gonna be on the bottom, pulling down. The middle is gonna be kind of like the middle deltoid, just pulling across, okay? All of the fibers pull in a direction of retraction. Think about it. All the fibers from the base of the skull all the way down to your lumbar are trying to bring the scapula closer to the spine. Every fiber is trying to say, come to the spine. So if all the fibers are pulling in a direction of retraction, then we don't have to be redundant. We don't have to say upper, middle, and lower. We just say the trap. No different than when we said biceps femoris at the knee. We didn't have to say biceps femoris long head and short head. We only said long head when it did something that the short didn't. So it's the same. When we get into components of the fibers that do something others don't, then we'll say upper, we'll say lower. But when they all do the same thing, we just have to say trapezius. Let's take another view of the retraction pull. Kind of makes sense? All those fibers trying to bring the scapula to the spine, pulling in that direction. Cool. All right. Upper fibers, I think this should be pretty easy for us to see. I'm going to save the hardest one for last. The upper fibers look to me like they have an elevation pull to them. And the lower fibers look like they have a depression pull to them, trying to pull down. The middle ones aren't a big region. Technically, guys, middle is literally whatever fibers are just pulling straight across that are neither pulling up nor down. So far, so good. All right, here's my favorite part of the trapezius. We have talked about a few times of force couples. Two different linear directional pulls that are actually trying to spin something the same way. We talked about if you were, let me get the computer to show this analogy. If this chair represented a merry-go-round and you were spinning kids and you were by yourself, I think the kids wouldn't be having fun. But if you had another adult on the other side of the merry-go-round to push or pull in the opposite linear direction, but it would be the exact same rotational direction, you could make it spin faster, right? Your torque would be more efficient. So what I'm trying to get at is, if all I tried to do was rotate this chair because of one push or one pull in the case of muscles, it wouldn't rotate as efficiently as if I gave it two forces in opposite linear directions, but the same rotational direction. Your trapezius, all the fibers, most of them, except for whatever happens to be right in the middle, but most of the fibers are very similar. What they're trying to do is, here's your spine. I'm going to keep it consistent on the right side. Here's your spine. Lower fibers are trying to spin the merry-go-round like this. Upward rotation pull. And upper fibers are trying to rotate the scapula the exact same way. So you get a force couple. You get something that's trying to spin down, working with something else that's trying to spin in the same way up. And then on top of that, you have the serratus anterior that's like, I got the bottom part. So you got serratus anterior working on the bottom, and then you have the trapezius, upper fibers pulling the top part this way, lower fibers pulling the bottom part this way, and you get a force couple of upward rotation. All of the fibers, save for whatever little bit that happens to just be totally across, are trying to rotate the scapula in a direction of upward rotation through a force couple. Something pulling up can work with something else pulling down in the same direction of spin. Make sense? And that's really cool. This muscle used to never make sense to me until someone explained how it makes sense. It's a very cool muscle. Has anybody ever noticed someone that looks like they have like a shoulder height discrepancy? Like one person's shoulder looks higher than the other, like on their side, and it's an arm dominance thing. Typically, like I'm left-handed, so when I'm not consciously thinking about it, my left side looks like it hangs lower than my right. But it's an illusion of muscularity. Your dominant arm, serratus anterior, is the same reason why you're winging in the non-dominant. Your non-dominant arm typically has very strong serratus anterior, just because you use it in a lot of activities of daily living. Well, when you do upward rotation type stuff, serratus anterior is working with trap through this force couple. So if my serratus anterior can pull more on the bottom, I don't need my trap to pull more at the top. But if my serratus anterior is pulling less, my trap has to make up for that side. And so that's why typically people's non-dominant trap is more developed than their dominant trap, because the person's dominant serratus anterior is typically more developed than their non-dominant serratus anterior. And that's kind of cool. I'm not asking it on the test. I'm trying to give you some purpose on why this stuff can eventually, well, you may be in grad school and be like, I already kind of know about this. That's kind of neat. Let's go back to our circles and our list. Who are the scapula elevators? Levator scapula, upper tract, rhomboids. Okay. Who are our protraction pullers? Pec minor, serratus anterior. Who are our retraction pullers? Levator scapula, rhomboids, trapezius. Okay. So remember on the test, if I'm asking about retractors and all of the fibers do it, I don't have to say upper, middle, lower. They all do it. I gotta say retraction. What about depression pullers? Pec minor in the front, lower trap in the back. Again, I love the simplicity of things canceling out. Heck, minor is a depressor downward rotator. Lower trap is a depressor upward rotator. Like this, I love the canceling out stuff. Okay. Upward rotators. Serratus anterior, trapezius, right? And then our downward rotators, pectoralis minor, rhomboids. Remember how the rhomboids are trying to pull back, levator scapula?
When talking about upper rotators, would we still group it as trapezius like you just did, even in the middle? Trapezius doesn't.
You're 100% correct. That is kind of a waffle. We would typically say upper and lower fibers because technically whatever happens to be in the middle isn't trying to spin me. It's just trying to translate. But I do want to emphasize that like 99% of the fibers are trying to spin me, and it's only like whatever fiber happens to be literally pulling on the axis of it. So like if it's a little bit on top, it can spin me, and if it's a little bit on the bottom, it can spin me. So like it's such a small little, but I would make sure that my answer choices weren't nuanced like that. You know, that's why I stopped putting answer choices like none of these. Like if you notice, I don't have that anymore. Because I don't want you to, to have to go through, oh wait, does it mean, right? Oh yeah, and I'm there too. But I would make sure the question is worded so that, a majority, like I would say, which of the following would be, or what are the functions of the upper trap? Well, if I just say upper trap, then that doesn't matter, right? Because the upper trap is a retractor, elevator, and an upper rotator, right? So I would find a way where there wouldn't be that kind of arbitrage.
What's the reason for having like a triangle on like this?
So I did that, because remember, this is all my stuff. This is all how I see these things, and I'm passing it along so maybe some of you guys see it. I brought these concepts to Auburn. They liked it. That's how they teach it. One of their people left to go to Ole Miss. He liked it. That's how he teaches it. So it's just kind of my visual. This is the only functional circle that isn't a cross section. This is literally a posterior view of looking at this. We're literally, and that's why the spine is there. You are literally looking at, you're looking like this. And so that little triangle is there to stand out like a sore thumb to say, oh yeah, that's literally like representing your scapula. That little triangle is just meant to represent a scapula. So muscles on this end are trying to do retraction pull, protraction pull, elevation pull, depression pull, and then having the little triangle there, I think is helpful, especially for the upward and downward rotation pulls. Because I think you can literally visualize it as a scapula, upward rotation pull and downward rotation pull. So it's meant to symbolize and represent a scapula on the right side. I'm glad you asked that, because I'm sure there was other, because this is different. Apple, banana, strawberry, sledgehammer. I've done a cross section the whole time, and finally at the scapula, because it's an articulation, not a true joint, it's kind of floating back there. It's easier for me to see the muscles, how they're pulling linearly on the scapula. To the spine, away from the spine, up, down, spin, spin. Now, I try to communicate that with our little legend, our little key. So, see, elevation and depression pull is going to be here. Elevation is going to be above. Pressure is going to be below. This is going to be our protraction, retraction line. Retraction pull is going to be on this side. Protraction pull is going to be on that side. So you see how, but again, it's different. We've never looked at one from a frontal view We've always looked at them from transverse view. But I just think it's a lot easier. It would be really hard to see scapula pull from a transverse view. It'd be, I won't say impossible, but it'd be very tough. Because we would have to see rotation in a different way. Normally we see rotation like this. If we did a transverse view, we'd have to see rotation like this. And that would be hard to see. So I just thought it was what was best. So recapping, I know it sounds like a lot, because it is a lot, but it's less than what we had on test 3. Wrist, elbow, well, technically radial and elbow, kind of similar muscles. Wrist, elbow, radial, shoulder scapula. Majority of questions, function. How does it pull? What are the functions of this muscle? What are the functions of that muscle? If you remember on exam 3, rarely did I give you an eccentric kind of practical stuff. It was mostly function and identifying an agonist and seeing if you could get the two muscles that would be an agonist together. If you remember, like, in other words, I'm using my dorsiflexors for whatever. I just need to make sure that the two muscles I identified are on the same team. So if I need wrist flexors, don't tell me flexor carpi and extensor carpi. Tell me flexor carpi and flexor carpi. If I need radial deviators, don't give me flexor carpi radialis and flexor carpi ulnaris. Give me 2 radialis. I think that's where most of the mistakes came, where you needed the dorsiflexor group, but you gave me a dorsiflexor and a plantar flexor. And I know why, because a lot of these muscles sound similar. Tibialis anterior, tibialis posterior. Serratus anterior, serratus posterior. I'm sorry, tibialis anterior, tibialis posterior. Flexor hallucis, extensor hallucis. Right? I don't think so much on these muscles. You know, make sure you know pec minor is a scapula puller, not a shoulder puller. So I actually think upper extremity could be a lot cleaner. And we have some awesome muscles like pronator teres, pronator quadratus, supinator. And we got some cool muscles that kind of help us out with pull. Levator scapula. Okay, so the positives, again, about trying to get through this is you have everything, you have all the information you're going to be accountable for as of Wednesday. Please look over it. Come Friday, and it's open mic night. I'll answer as many questions as you want. Please use exam 3. And remember, guys, I'm trying to teach you not to memorize stuff. I'm trying to teach you to have these tools that you can apply, because, you know, a math book can't have every math problem in it. There's just too many. It's infinite. But if you know how to add, if you know how to subtract, you know how to multiply, you can figure out whatever problem comes to you. But the test won't be any different in terms of the types of questions. Very heavy on function, somewhat heavy on stretch, which is indirect to function. If it's a protractor, I'm going to stretch it by retracting. If it's an elevator, I need to stretch it by depressing. That kind of stuff. If it's a flexion puller, I'm going to stretch it by extending. So even the stretchy questions are functional, because if you know how it pulls, then you know how it could be lengthened. Make sense? All right, we're good? Your test is on Tuesday, am I correct? Tuesday at 6 o'clock in the morning? No? I think it's at 10. That's what I thought. Better to get you here early than late. All right, y'all have a good one.